So in this lecture we will see what are the different corpus of sentiment analysis, and we will again see some kind of analysis that people have done on those corpus and how we also can do those kind of analysis. So there is a corpus named as General Inquirer given by Stone. So this has 1915 positive words and 2291 negative words, and it's available on this website, right? Then we have linguistic inquiry and word count corpus. It is having large number of classes, large number of sentiment classes, right? Negative emotion, positive emotion, then again cognitive kind of classes are also present here, right? Then we have one more MPQA subjectivity cues lexicon. Okay. Then we have Bing Liu opinion lexicon. So we have these kinds of lexicons, and we have SentiWordNet, which is again a very popular corpus. So we do have a WordNet, that is an encyclopedia of words which contains a lot of information about the words present in English dictionary, right? So that WordNet also contains the sentiment of, or sentiment score of a particular word. So if we have this word estimable when taken into meaning of maybe computed or estimated, there is no positive or negative sentiment, but there is an objective sentiment, that is one assigned to it. So this is actually the probability of among these three classes, right? So but if we take the estimable in the meaning of deserving of respect or high regard, so it is a positive kind of word and not a negative word. So that's having the probability of 0.75 and the objectivity of 0.25, right? So we can also access SentiWordNet, can be directly accessible through its libraries, and it's freely available over the internet. You can go on this URL. And then some people have done, especially done by the Christopher Potts, he has analyzed all these four corpus, and then he has given some counts based on the disagreements. So disagreements between the opinion lexicon and MPQA is there, that there are 33 disagreements. So what do you mean by disagreement is that the MPQA corpus may be telling a word as positive, but opinion lexicon corpus is telling that particular word as negative, right? So so these corpus are in large very much in line with each other. Very low number of disagreements are present, right? Now Potts have again done another kind of analysis. Now he displayed a graph of counts of bad in IMDb database. So there is a word bad, and then he has counted the word bad in each class of IMDb dataset. So there are 10 classes, and people give ratings from 1 to 10, right? So 1 is the lowest rating, that is the poorest rating, and 10 is the highest rating, right? So we see that this one rating of that the count of word bad in this poor rating, in rating 1, is very high, and it's obvious that there will be large numbers of bad in this rating. But we again see that in this case the counts of bad is also high in the 10th rating. Now what could be the reason for this? So he studied and analyzed that the count of word bad in 10 is high because these are absolute counts. It means that the number of 10 rating comments are very large in number, right? So that's why the number of counts of bad with respect to 10th rating is large. So as compared to this 2, 3 or 4, this the number of comments that are present with the 10th rating are very large, right? So the total counts is actually large. So we need to some way not go by the raw counts, right? So we can calculate the likelihood and then perform the comparison of bad among different classes 1 to 10. So the probability of word bad for a class, for given class, may be calculated by the same formula, that is frequency of word in that class divided by the total number of words in that class. Right now this probability becomes now class respective, right? Frequency of word bad in class 1 divided by total number of words in class 1, right? Similarly, frequency of word bad in class 2 divided by total number of words in class 2, right? So in this way it can be normalized, these parameters can be normalized, and then we can relatively study the behavior of any word across all the classes, right? But another problem is that whether we will be able to compare these parameters between other words or not. Now if I want to see or want to compare the word, say, good or poor, if I want to see the word poor also, right, and I want to see the comparative between poor and bad. So now how would I do that kind of comparison in relative? So relative of bad with respect to these classes, we can use the likelihood of word bad with respect to each class, but in order to do the analysis relatively among the words, we can calculate it with the help of scaled likelihood. Now we divide the probability of particular word given class divided the probability of that word as a whole, right? So in this way we are dividing the probability of particular class probability of a particular word by the probability of the same word as a whole class, sorry, as a whole corpus, right? So in this way we will be able to compare different sentiment words in a given corpus. So we see here now the curve of bad, which has to be something like, it should be go like this. We can see in by applying these parameters with the help of scaled likelihood, all the words come to the same parameter, and on the same graph we can analyze with each other. So we see that the word bad is having now very theoretically analogous graph. In rating 1 it is having high number of score, and in rating in class 10 it is having a low number score, right? And for amazing, we see that in lower classes it is very low in number, and in high class it is high in number. Similarly for great, so these are the positive sentiments, these are the positive ones, and these are the negative ones, right? So this kind of analysis can be done by calculating the scaled likelihood, right? Similarly, he again went to do the analysis of the negation words, and he found that these negation words are also in the same corpus. So in lower words, the negation words is having some kind of high score, and in higher class these negation words are having low score, right? So this kind of analysis was done by Potts in 2011. Okay, so that's all we have done for today.